Okay, cool. Thank you. Yeah, now we will be talking only about SAML 2.0. Okay, and we will be discussing first formally define what is authentication, what is authorization, what is an identity. Okay, so we would have learned, we would have know terms like username, password, roles, right? But those all come under one umbrella of identity. Okay, so we will learn about that. We will learn about a custom authentication scheme, and we will not go deep into LDAP. LDAP is something which I will give you some insight, and I will also give you some links as to why we cannot use LDAP successfully in modern cloud architectures. Okay, so I will explain in some bit, but not fully. I will be able to explain because that is out of context. Okay, and this part will also talk about some of cryptography, which you might have already learned in that Harvard University's training, where you know about encryption, decryption, signing, and verification of signatures, right? So that also I have a link that gives you a quick overview. But the main idea is that you will do a encryption using a public key, and then it is decrypted using the private key. Let's say you have things like that. I will come to that. So I'm just giving you overview of what will be discussed, right? So now we will talk about the SAML jargons, right? There are any new thing you learn, you will be confident only when you know the jargon, so you have a common language to speak. So that will be identity provider. You will have something called a service provider. Trust between IDP and SP. That is, IDP is an identity provider and service provider. And we will talk about things like subject, SAML, metadata, name IDs, right? We will talk about all this. Okay, and then so we will talk about what is called a single sign-on URL for this SAML protocol. Okay, and we will talk about how to construct a SAML request, and how you will create that and send that to the IDP. That is, in this case, the context is the IDP which we will be taking is only Okta, so we will discuss it in that context. Okay, then we will we can go more and more, like you can decode it, which I will show. That there is a dev tool, Chrome developer tool called SAML dev tools, which can decode that token with some jumbled data you will get as a SAML that you can see as an XML. Again, the main point I want to make you is SAML is something, a technology that was invented when XML was at its peak. So XML is a technology that is used, but SAML is widely used by many companies because of the of this advantages it has. And like every tool, it also has disadvantages, but it is widely used by many companies. So that is the interest which we are showing in this particular training, right? Now there will be a lot of diagrams that will illustrate you the idea. Okay, and we will talk about as we go in, we will talk about the fundamentals of an identity management system. Then we will first start with brainstorming a custom security architecture. Why can't we have our own architecture, right? If people who might have used Django, or even Java Spring Boot, or Ruby on Rails, or Laravel, everything has its own architecture where you can use your own database, can have everything, right? User roles to user IDs to passwords. So why does it not fail, and why do we need an IDP? So we will start from that, and then we will talk about what is called an identity provisioning. Okay, and then we will talk about delegated authentication. So delegated authentication comes as an alternate to why we cannot use a custom architecture, that is a custom authentication structure, right? So let's hope this introduction as what we are going to cover makes sense to you, right? Okay, let's move on. Yeah, so to begin with, sorry, the login page has come first. It's not supposed to, but yeah, we have a web application. Let's assume that this is a monolithic application, nothing complicated, no microservices, nothing. Okay, so we will start with, we want what? Authentication and authorization. That's our scope, right? So let's say we have a database, right, and we have one user who is trying to use a user agent like a browser to log into the web application, and that is connected to a database, right? A very simple thing, right? Now the web application should give only access to the users which it considers as valid user, right, or valid credential. So where do you store that data? So let's say that I'm talking again, this is a custom architecture which we are imagining why we cannot start with, right? So why can't we store it in the application database itself, right? So let's say that we are storing it in the application database. Now please know that this identity or this user ID and password, which is shown on the left side, username and password, is what you will find. You will be known to you as the source of truth for this application, right? So you from this it is very clear that this application is in charge of business logic. The database has application data, right? It stores the user identity, and the web application does the authentication part, right? So it is very clear that this authentication and even the authorization of roles will be taken care by the web application, right? So what is authorization? We will come to the formal definitions, but when I say authorization, there are cases where some users need to be given read access. Some users should have administrative access where they can virtually create, edit, delete, and then do other settings related operations, right? So these kind of rules define what the user can do and what he cannot do. Okay, now in our this example, we will have this user role also inside the database. Where else will you store it, right? Now what happens is that as soon as you have this web application and you authenticate, the web application performs authentication with the help of the database. It creates does the authorization, then it creates the a session cookie, and it creates a new HTTP session. Everything is fine, right? Now let's go deep into the because we will talk about this again and again, and this is only the framework of authentication and authorization. Let's talk about what is authentication first, right? So authentication, it means that it is the act of recognizing that the user who logs into the system is a legitimate user, right? So this user has to be the correct person with the right user ID and password, and user ID and password is what we normally use for a legitimate user. Okay, this is called authentication. Now what is authorization, right? Now authorization, on the other hand, it is the act of making sure that the user can perform only the functions that the user is allowed to perform and nothing more, right? So let's say you don't have access to edit your profile, right? So you cannot you don't have that role, that permission, so you're not allowed to do that operation. So these users or these ability to perform such functions are modeled in the form of roles, right? So I have talked about authentication, I have talked about authorization. Next we will talk about a concept called identity provisioning. Okay, so now you have to create initial passwords. Any application you take, all the frameworks I mentioned, you have to create these initial passwords, and then you also have a concept of rotating the user passwords at regular intervals, right? And then now who is responsible to doing this in this particular case that we take, right? But ideally we will come to that we ideally we say that it is supposed to be taken care by the identity management system. But in our scenario, who is taking care of that, who is supposed to take care of that in our customer architecture? It will be the application itself, right? So that is creating the user roles. When I say a provisioning, that means creating the user initial password, roles, everything, whether you want to do it in a UI, whether you want to have it as a script, right? So all these things, who is responsible will be the application. Now identity provisioning, also authorization authentication has to be performed by the application. Then the identity provisioning is also has to be done by the the application. Now, so what does this architecture look like? Let's see a diagram, right? So if you can see this, you can see that there are so many web applications, all have their own databases, and each database has its own set of username and password, right? So yeah, this is not restricted to username password. You see that the username password itself is different for each web application stored in the database, and different as different records for every user that is entitled. That is, user 1 is entitled to user web application 1 and 2. So user 2 is entitled to web application 3 and 4. So this has to be stored as multiple pairs. And this is not just only just for the username and password, but also for the first name, last name, and everything else, right? So now this being said, you also notice that in this particular custom architecture, the credentials are sent to the application. So I can show you that. If you go to that particular screen, it's clear that the credentials, the login is sent to the database, right? Sorry, is sent to the application directly. So you are not supposed to send the credentials to the database, and you should centralize all the identities in one place, right? So what we are talking about, what are the problems of this custom architecture, this security architecture, what problems do they present, right? So what is the first problem? That the user identity is duplicated, and the user has to remember too many passwords, right? And the application is responsible for user provisioning, which is very obvious. And in fact, the provisioning and deprovisioning of users itself is unmanageable. Okay, and there is no single sign-on. This is a very important concept. The buy-in of any of these delegated authentication tools is this single sign-on. You don't want to keep signing on with even 100 combination of user password you have on your machine, right? So this is very important. And the application is also responsible for the multi-factor authentication, right? So credentials should never be sent to the application, and we want the identity to be in one place, right? And all other these scenarios. So far these are the problems that we see with the and one more thing is that again, like I said, credentials should not be sent to the application. So before we go to the solution part of it, right? What is the solution? Any questions, anything related here from the team that has joined online? Is my voice audible? Yes. Yes. So any doubts? No. So far so good. Okay, looks like it. Okay, now let's go to the solution part of the custom architecture problem, right? Now what is the solution to it? Now you centralize all the identity to one location, right? Then you introduce the concept of a identity management system, right? So what is the architecture that we are advising here, right? We are advising an architecture like this, right, where you have a centralized identity management system or identity service or identity provider, whatever you call it, as a centralized one that stores all the username and password, right? This is what we are advising as the viable way of managing authentication for multiple web applications that are even monolithic. I have not even come to the point what will happen if they are put on the cloud. Just monolithic web applications, multiple. Okay, right? So yeah. So we are talking about this kind of authentication where the web application considers trust the identity service. This is very important. This is a very important term in security by itself, that you establish trust with between two entities. One is a web application and the other is the identity, and trust is something which you will see commonly across the security domain, right? So you establish this trust. Okay, now so user data, when I say the identity provider has to perform these services, right? It's a service, right? So what service does it provide? It has to store user and group data. So what are the user and group data it can store? Like it has to store user credentials, first name, last name, the email IDs, phone number, even picture, right? You will see, you would have seen it in our internal sites, our Slack applications. Even if you have used use something like an Microsoft AD, which uses pictures, right? That will propagate to multiple enterprise applications, right? So, and groups. Now this groups is very important because the group defines the role to which the user has rights for those applications to which the roles are assigned to. So, and even the manager, right? Who's your manager? So these are the data that will be stored by this identity management system or these services, identity providers, right? So now coming to the next thing, here I have said that LDAP, no LDAP, because LDAP is not in the scope of our discussion here. But remember that Active Directory is one of the leading providers of identity services, but they cannot work on their own because of certain limitations. Main limitation among them will be that it will not work for the cloud, for the sole reason that when you see an architecture where let's say that you have to connect to LDAP from AWS cloud, right? You have to open some TCP port in order that communication to directly happen to LDAP. But those ports, for security reasons, are never open. So for that simple reason, it is not advised and it is not possible to connect a cloud system to LDAP. Okay, I have given one YouTube link. It will be at the end, but that defines clearly what are the other limitations. And again, single sign-on is not possible on LDAP because every LDAP system can have its own user created, right? And there are, one mentionable reason being that LDAP will also send credentials to the application. That is not stopped. LDAP is not an identity management system. It could be an IDP, but it is not an identity management system. Okay. Now, hope this is clear, right? Can we move on to the next? Yeah. So, we will be talking about a delegated architecture, right? Next, we will be talking about a delegated architecture, as I promised. So the alternate for our custom, so the custom application architecture doesn't fly, right? Even our LDAP has limitations. So what are we trying to do here, right? What are we going to do, right? So we will be going for a delegated authentication. That is, we will delegate to an external identity system that the web application can trust. That is, when the user authenticates, or let's say the user itself is unknown or the session doesn't exist, then the application should request the browser to redirect to another trusted party, which will ask for the credentials. So the credentials will be sent only to that trusted party. So this trusted party is called the identity management system. Now, compare it with the identity provider like LDAP. It's not an identity provider, it's the identity management system whose sole responsibility is to front end whatever authentication authorization you are doing and compute the result and give you the output, which is the response you want, right? So that is what is an identity management system. And the trust which I spoke about of the identity management system, this is the trusted party, right? This trusted party can be considered to be one by a web application by means of exchanging some keys, which is public and private keys, right? Again, this concept of encryption decryption you would have learned in the Harvard course, or you would be aware. Right, so I mean, when the Harvard course is detailed, but I have given attached a YouTube video which gives a gist of what this does. So let's say you have the request to be sent to the IDP. So the web application should encrypt using the service providers, that is the service providers public key, and it will be decrypted by the private key, the identity provider's public key, and it will be decrypted by the identity provider's private key. And similarly, signing happens by the service provider's public key and it will service provider's private key, and it will be verified by using the service provider's public key. So these are things which you already would have known with the Harvard course, but I have given a link which will explain this. But know that the trust is established between the identity management system and the service provider only by way of this public key and private key. Okay, and I will come to the part where why are we doing this encryption part? What is why we let's say REST, you take REST API, we don't bother to encrypt or decrypt it, right? So I will come to that, but just keep this in mind that you have to encrypt, decrypt, and not just that, sign and verification is also needed for the that data, right? So far we are here.
So one thing managed.
Yeah. So we'll go to the previous slide.
I think it's something here. So you're saying that the identity management system is supposed to get the credentials directly from the user.
Yeah, he will be getting the credentials by by two ways. One is he can have a redirect of that browser request, or he can have an HTTP post, which will be like a JavaScript compost, which will post that credential. So it will be a fresh request from the user. It is not like the web application or the service provider is trying to give the credentials to this this identity management system.
Okay.
It is the user.
Login page and all, it will be implemented by web application.
But it is the identity provider which will give its login page, the enterprise login page. Yeah. So that is the one. That's a good question. That's a very good question to ask. Yeah, thanks for that. Now, okay, we are here. Okay, now this is what just what Prabir asked is so this is how the user experience will be. That when the user accesses the web application has to delegate the authentication, but it only delegates it through the user agent. This user agent is very important, that the web application is not sending anything directly to the identity management system, but it is relying on by means of using an HTTP redirect, so that a 302 request will be sent to the identity management system, or HTTP post, a fresh HTTP post with the username and password will be sent to the to the identity management system. In which case, this username and password will not be known to the to even the identity management system. The identity management system also doesn't know at this point, because the user has not been presented with the login page. So what the identity management system does, in this case, the identity management system which we have in mind is Okta, and Okta will provide its identity, its login page. So you get the user credentials. So this is what is explained here. So when I please don't get confused that okay, I have built a web application, I have a login.jsp or I have a login.py, and how is that the IDP's responsibility to show that. But when you come to the world of SAML, when you come to the world of delegated authentication, it is the responsibility of the IDP to even show you a login page. You can customize that login page in your application, but it is up to the identity management system to show you that login page. Like say for example, you have Windows system, right? So you have that Windows dialog box that will intercept any Azure or anything you use. It will use your enterprise credentials. So that is similar like Azure, which is which can be considered as an AD, Active Directory service, which it is, and it is also something that is a identity management system. So similarly, you will get the Okta's identity, Okta's login page. Okay, so so I will again there are links which about the previous LDAP and public and private keys, which I will share. Okay, then now what are the advantages of the identity management system? The credentials are being sent to the identity management system directly, because identity management system is showing its login page, and you are sending the credentials to the identity management system and not to the web application. And there is no direct communication between the web application and the identity management system. It is only an HTTP redirect or a new fresh HTTP post call which will be happening between these things. So this is a trust which we call that is established between the IDM and the web application. Okay. Now I think we have discussed the concepts of delegated authentication. Now we will talk about the specific one, which is the main topic here, right? Which is SAML 2.0 single sign-on. So we will talk about the SAML theory itself. So things like identity provider, service provider, trust, which we already learned, SAML metadata, SAML assertion, subject or a user. Then what is a protocol binding? Again, protocol binding, I already mentioned HTTP redirect or HTTP post is a protocol binding. And we will talk about two different types of SAML authentication flow. One is the SP initiated, that is service provider initiated SAML single sign-on, or the IDP initiated SAML single sign-on, right? So moving on. So again, sorry for the introduction. Again to the introduction. So I put it like that. Okay. Now, what is SAML? Now we have not even touched that. So SAML is the short form for Security Assertion Markup Language. Again, it's a markup language. It is based on XML. There are several identity management systems available. Things which not just support SAML but also other delegated authentication systems like OIDC and OAuth. So these are Okta, ADFS, Ping Identity, and other IDMs from the major corporations like Oracle and IBM. They are all major players in this market. So this is not some small market that you are talking about. This IDM itself is a big market for many companies worldwide. Okay. Yeah. Yeah. Now this is a very important diagram. This is a very important diagram because here we are talking about our own enterprise, which has its own identity management system. So here we are talking about SAML. So we are having a SAML identity provider, right? And we have our web application, which is a SAML service provider, and we said that it establishes a trust first. That's the first thing it does. And you have other things like user and multiple user agents and the database, of course, right? Now this SAML identity provider talks to the SAML service provider, talks to the SAML identity provider through the browser and not directly, right? And then the like it is shown, the SAML identity provider and the SAML service provider. they can reside in different data centers. So enterprise is your different data center, AWS, it can actually theoretically reside in a different data center altogether. Right? So far so clear? Okay. Yeah. Now when we I think identity provider I already said, now we are using SAML, right, which is responsible for taking in the request, not just logging in. That's not your only intention behind having an identity provider. You have to take in a request, and then after you compute the username password, whether it is entitled or not, you will send back the response to the to something called a relay state. We will come to that. Okay, and we will also talk more about a user or the subject, right? And then the subject has to use a browser or the user agent. Again, this user agent is very important because the SAML service provider cannot directly talk to the SAML identity provider, but only through the user agent. Okay, so this is a very important diagram, and this trust, how we establish this trust will be illustrated at the end through the Okta portal. So we'll go to that, but we have kind of covered half of what we have so far, but we will go to that place. Now this is an extended diagram. This is just that you have, instead of one single cloud provider, you have two separate cloud providers. In each case, the trust is established with the same identity provider, right? Now there is one very important point here. When you establish trust with one single identity provider, that means both the web application 1 and web application 2 knows the identity provider, and the web application 1 has logged into the identity provider. Now what will happen if the web application 2 tries to log in? Can anyone say what will happen if the web application 2 tries to log in? Anybody?
Authentication, yeah.
So yeah. Yeah, so this is where the identity management system already sees that the user has been authenticated through one system, and then it passes on into an SSO mode, and then logs in the other user into the other web application as well. So this is very important in multiple clouds. This is the biggest sell point when it comes to the single sign-on part of it. Okay, so this is very important. Again, I will repeat one more time. When the web application is two web applications, let's say in different hosted clouds, are established trust with the same identity provider. When the web application 1 has logged in, then the web application 2, when it tries to access that web application, it will be allowed by way of already having been a trusted entity by the identity provider, right? So this is very important.
What's Active Directory and directly?
Yeah, so LDAP, you cannot only directly talk to the Active Directory for an identity management system, but the values of the username and password will be verified against the LDAP service. Though I missed it, but even in the previous diagram I didn't mention it, but that is very important because we use SAML so that this LDAP don't have to be thrown out, right? Because Active Directory and HDFS are very key part of the authentication system, especially Windows-based authentication system. So this identity management system solely delegates the verification of the login. Okay, and any other encryption and then trust part is taken care and is only managed between the identity management system or the SAML identity provider and the service provider. The trust is not has to be established with the LDAP. So LDAP cannot say that you have to open me this particular port. That port will never be open for them because it's a security threat. So that's the point here. Anyway, that's a good point to bring out. But yeah, that's something I missed here. Yeah. So this again is a very important point about the trust established between two different multi-cloud environments. Okay. Now, so we will talk about the SAML authentication flows. So, like I mentioned before, there are two different SAML authentication flows. One is the service provider initiated single sign-on, and there is the IDP, that is identity provider initiated single sign-on. So, so when the in each case, when I say establishing trust, right, I should also say that you can, we go to the Okta exercise, we will see that you can use the SAML identity provider, that is Okta, generates a metadata, right, and that metadata can be just uploaded or scrapped and then put some parts of it into the service provider, and then the same can be done by the service provider as well. Okay, so this is one part you need to understand. When I say that arrow that is shown trust, that trust is established by way of something called a metadata that is generated by the IDP. So you put some attributes that are inside that metadata at each other's place, so that the IDP knows about the SP and the SP knows about the IDP. Okay. Now, in addition to this, in addition to establishing a trust, we also have to assign users, because you have to finally trust not just the application but some users that have to use this web application in the future. So we will also establish the trust of some users. So we will tie some users to the identity providers, right? Then we will also configure as part of the metadata configuration, this trust configuration, single sign-on URL. So you will be configuring two URLs here. One is called the single sign-on URL, which is the URL that will be sent to the IDP to seek for authentication, and there is another URL which is called the ACS URL, which are or nothing but the assertion consumer service URL, which is the URL or which is the resource you are requesting for. So let's say I request for it, then you initiate me a single sign-on request. So that is those are two configurations or distinct URLs. Please note that these are two distinct URLs. There are two other URLs also, or I would say rather, two other URLs which will be used for protocol binding. But for now, these two URLs are very important. Okay. Then, like I said before, there will be these the other two URLs or for the protocol binding. There's a redirect URL for and then a post request URL. All this will be explained subsequently when I actually show you the demo, right? Now the SAML response, right? Now you have trusted, you have sent the credentials to the IDP, and the IDP has done its part of connecting to the directory service, and then it has found that everything is good and it sends a response, right? So what does this response contain? This response contains user attributes or nothing but subject attributes. That is, the response will have what is called a SAML assertion or a SAML token. Okay, this each SAML token or a SAML assertion contains all the attributes of the user and also the groups that are associated with the user. And like we said before, the attributes of the user will be used for authentication, and the attributes for the group or the group attributes will be used for authorization, right? Now, this SAML response will be sent to the other URL I was talking about, which is the application URL or the ACS URL, the assertion consumer service URL, right? Now this whole entire thing, this assertion, all the assertions will be contained inside the SAML response, and you please understand that the assertions have to be encrypted, which is an option, but they have to be signed and validated by the service provider. It doesn't mean that the identity provider has sent a SAML response and everything is okay and the service provider will accept it blindly. It does a verification on its side, whether it is the right assertion or not. So we will come to that part.
One question on this one. So we are saying that the SAML response will have the user authorization detail as well.
Yes.
So
user related detail. User related detail. If the user is authenticated, then you will get the correct user related data. So I will give you an example. Let's say I request for my first name and last name. right? So if you are authenticated properly, you know that your first name and last name is configured as Prabir and Vishwas. So that it will be available in the response that you can you get, but it will all be encrypted, encoded, all that. But you can see that using some tools, which is something I will show.
Okay, so that is user related data, but not the authorization, like groups or.
The group data also comes. Group data, when you say this particular total response as a whole will be valid only between this part and this part. That will come. And then other related group data will also come. But in this particular example I am going to show, I have not created a group actually, but group data also comes.
Yeah, but my question is then how it will be different between two different services or multiple service providers, because they all have different groups. So I have authorization, some different authorization for this.
But we are using a single identity provider, right? We are using a single identity provider, and the identity provider has a common place where you can define all your users and groups.
No, I mean how this will be differentiated between different service providers. You are saying the same trust will go to this guy also, so everyone will get it.
So I mean, if you think about it, right? My identity provider is one, and he will have the same user ID like P Biswas in that identity provider. So if you're logging in as let's say Prabir.Biswas or P Biswas in two different applications, your identity provider knows it as P Biswas only, right? So it will authenticate that.
I was just thinking about the authorization because groups like in Google, I am like an admin. While in AWS, my group may be something. So when the data received by Google and when the data received by AWS, both have group details. Something. I don't know. That's why I got
This is not AWS related data. I'm talking about web application. Web application that run inside those AWS and Google. Yeah.
I understand. So, okay.
Yeah. So, I mean, it is not that AWS credentials and then Google credentials can share. No, not at that level. It is at the level of the application. Application. Yeah. Everything at the level of the application. Nothing more than that. Yeah. Okay. Now, so moving forward, this is what is called the SP initiated single sign-on. Again, we will go over it one more time. The user accesses the application and the application forwards the request to IDP because the IDP hasn't found any user. The IDP displays a login page. The IDP is responsible for authenticating the user and the IDP will forward the response to the application. This is in this you will see that the service provider has to initiate that number 2, right? This line number 2, which is responsible for this whole operation to kick off, and then you end up with line number 5 indicated, right? So that is why this is called a service provider initiated SAML SSO, right? And you have two different entity IDs, and in SAML, entity IDs or how you identify a system like a SAML identity provider or a service provider. Again, when you establish trust, you will say that I established trust only with this entity provider. So did I get the response only from this entity provider or not? So this is also important. This entity ID, we will also see that when we see the demo. Okay, how this entity IDs are verified.
Sorry, one quick thing. So in this flow, the trust will be established when these servers are up or something, right?
That will be it will be when it is.
It's not in this. When the file is saying file, this is basically when the metadata is.
Trust has to be established first. That is the first operation you have to do. Even before you establish trust, you have to create users. You have to create one application first. You create an application, then create users for that, and assign the users, and then establish the trust using metadata. Okay. Yeah. Now, so this is so. Let's move on to the other SAML SSO type, which is the IDP initiated SAML SSO, which you might have seen in many places. People who are even in contrast, where they have, you used the Okta portal. So you have portals of multiple applications, right? So that is what is we are going to talk about, right? So we have a scenario where the user, the web application is not the one which is going to initiate this particular login into the IDP. So you already have a have your applications, and they are all integrated with the IDP, right? And then this IDP knows all its applications and all the users of this application. Like even let's not go into a specific project, but let's say Microsoft Azure, right? It has Microsoft 365. So it has a PowerPoint, it has SharePoint, it has everything, right? Excel. So all these applications, the identity provider, which is the Microsoft Azure, knows all this. But now the problem is, if you are using a single integrated enterprise where you only have Microsoft 365 and nothing else, then everything will be using the same Azure. But there will be a case where you have one using has to use Azure, other using SAML, and other may use OIDC, right? So we are talking about where you have an enterprise user who is shown a dashboard, and these applications can be redirected to any other page. It need not be SAML, it need not be just LDAP or AD or Azure, or even OIDC or even OAuth. Right. So how we are going to do this is by means of what is called the IDP initiated single sign-on, because we need a single sign-on, because we have, just because we have multiple the same problem, the multiple identity providers, we don't want to have multiple logins happening because of that. So how do we do that? Right. So we have a dashboard. First of all, the user will be given a dashboard URL which is for logging in using his username and password. So he submits it to the identity provider. Now you have to understand here that this is a corporate environment. So if the user is logged into the computer using the same corporate environment, it is quite possible that this particular portal will already know that, and if you open that particular portal, let's say it is myportal.com, it will already open that page without even showing you this login page. So that is the importance, that is the difference that you will find mainly between the IDP initiated, because the IDP knows all its applications and it is an enterprise level one. It is not something just because you have clouds, it doesn't mean that it is outside of any enterprise. It is enterprise, it is including of the enterprise, right? In fact, if that is even not the case, you will be allowed to log in, right? You will be validated against the directory service, and then you will be shown one response. That response will be validated and verified, and if everything goes fine, then you will see the list of applications which are known to the IDP, right? So this is called the IDP initiated SAML single sign-on. Okay, so these are very important concepts. Okay, so yeah, so let's move a little far, because we are coming to the part where we have been talking a lot of theory without any hands-on. So we will be doing some hands-on. So we will be doing experimentation, SAML experimentation with Okta itself, right? We will be constructing a SAML SSO request, and we will analyze the response. Okay, quickly we will analyze the response. You have to sign the assertion. The assertion can also be encrypted, but it is an optional for the protocol itself. But signing an assertion is mandatory for the SAML protocol, but encrypting the assertion is not. So is for the response. So I will be showing you where the assertion will be unencrypted, but it will be signed. Okay, and we will do some debugging SAML using Google Chrome. You know, everybody knows Google Chrome, and there is a SAML DevTools extension in addition to the normal developer toolbar, right? And also there is a samltool.com site actually, which will help you in verifying SAML. right? So we will do that. For that we need to do some Okta setup, of course, right? So when I say Okta setup, the first thing you would all would love to do is go to the Okta site, right? So you can see the Okta site here, right? So I can scroll. Okay, yeah. Now don't go for the first option, though it says return. Don't go for the best for developers, all this stuff. Go for the this one. Go for the Okta Developer Edition. Okay, don't go for first identity cloud or first identity cloud. Go for this one. Sign up is free. Okay, and sign up. When I say sign up, you have option to continue with Google. You have work email. You can give that, or you can also continue with GitHub. In my case, I already had an account, so I was actually lazy to create another account. So I continued with my GitHub account. Okay, so that is what I will be using here. Okay, so so now you sign up using this particular one, and we will come to that part where I will sign in and show you the dashboard. But I want to say that this is a demo, right? So we have an identity provider, which is Okta, already said, and we have a Python dummy Python application. Now this will serve as the service provider. Now this is a demo, so we're not going to write anything very complex, so don't worry about it. Okay, it's a very simple Python program. I'll come to it. Okay, and then we will construct a SAML request, and then we will inspect the signed SAML response. And again, like I said, we are not going to do any encryption, and there will be no SAML groups in this, right? Okay, now we will talk about all these IDP SSO URL. What is it? What is the ACS URL? I think we will see what this ACS URL itself is. So again, you have to create a trust relationship. Even if it is a dummy service provider, doesn't mean you cannot create a trust relationship. Even it is a service provider, so you have to create a trust relationship, which we will do in Okta. Right? We will do it in the Okta developer console. Right? And then now what will happen is, when I say trust, establishing trust, what is the output of this establishing trust? We will see that it will be a metadata. This metadata is needed as attributes which you will share between the SP and the IDP, so that there will be no confusion when we do the verification or the decryption part. Right? No, that is when you establish a trust. At that time you will use the metadata. So when you do the request, the request will be only for the request will do the decryption part. Decryption, when it will decrypt by the algorithm which is specified in the metadata. Right? Nothing else can happen. It is not that the intermediate party can use some other algorithm and try to decrypt it.
So this request will be coming from IDP to service provider or the other way.
Yeah, so the initial request will be when you initially log in, right? So you will be sending one SSO URL, right? So you will be hitting always the SSO URL. So that's what I quickly try to skip, but you caught me there. So this IDP SSO URL, this number one, this URL is what you will hit. Okay, and to this URL you have to pass the SAML request. Okay, and this SAML request has to be.
That's what I didn't understand. Who created this request?
So that let's say that is that's done by the browser. That's done by the browser actually. Browser only. That is so you have the URL is something. SSO URL is just a URL. Okay, and the SAML request is something that the authentication module has to perform. or let's say you can say that a module of the web application can do that encryption part, but it can only be done by the allowed, that is agreed upon trust. Let's say that I say that my my encryption method is RSA 256, and then I have to do a signing using to a SSH 256. It is only by doing this encryption and doing this signing I will be able to even go past SAML. Web application can do that, but only if it does based on the allowed. That is whatever was established by the trust using the metadata.
This URL is basically go through the service provider.
It has to directly goes to the identity provider. Web application is only involved in creating that request part of it. Let's say that IDP is some HTTPS // something .dev /SSO /SAML question mark SAML request is equal to whatever comes after that. That computing part is only the part which is SAML, which is just an operation, right? So your request doesn't have any login detail or anything. So it's just I will show you the request.
I will not hold you. We'll discuss.
Yeah, we can discuss later also. Yeah, because I think we skipped the time also. So let's go quickly. Yeah. So like again, I am a bit lazy. So and also for the sake of time, right? I will be logging in now. That I will do. Okay. Right. Okay. I already logged in. Already logged in. Okay, sessions and keep. Okay. So it's good. Yeah. So I have already created an account using my GitHub account. Okay, now let's quickly go over some of the things which we will be doing here. So the first thing first is you will see the dashboard. I mean, these are actually tick marks, but why it is showing like this? Maybe it is because we are having a free version. Okay, so but there is a tick mark here. Okay, now go into people, right? Here you will create your new user. If you want to create another user, you can create another user. So this is my primary user. And you will see that his first name is Weldon Mission and last name is also the same, right? And he has an email ID of this one. This is provided by Okta as an email ID. Remember this because these values you will see later on. Okay, so first name of Weldon Mission and last name of Weldon Mission, right? And how will you add a person? You have to. So this is again, these are parts which I will discuss. But these are UIs which you need to be familiar with, which you will be using often. Then you will have a option here to add authenticators. That is, you have a user and you want to change. You have to set some authentication, password rules, right? So that you can do by going here. And you want to have some multi-factor authentication, you can have any multi-factor authentication. Okay, so these are also there, right? And in addition, the first thing which we will do, like we said, we have been keep on talking about the same thing again and again, that we have to establish a trust. So the first thing that you will do by establishing a trust is that we will do this, create a app integration. So that is how we establish trust to begin with, right? So again, I have done this again. I have done this before. Okay, so I am not going to do it again. So this particular app integration is what going to be created. But I will show you the screens. Each screen. Okay, when you do this, this one, the very first page will be the SAML 2.0. So you select SAML 2.0. Okay. But like I mentioned before, this Okta is not limited to SAML. It has other delegated authentication mechanisms also. And you can give the name and logo. And I want the logo to be displayed to the user. So I'm not going to check these. Right. Then see these values, when you say single sign-on, again don't get confused. This single sign-on URL means the ACS URL or the Assertion Consumer Service URL. Maybe it's a confusion in the terminology. This is not the URL which you will hit to go to the IDP, but this is the URL which is needed so that the IDP SSO will be initiated. That is, IDP site SSO will be initiated. This is the ACS URL. So please understand that. Don't get confused with what terminology Okta has used. It is just the name they have given. It's just a label. Okay. So we are going to again. Before even going that, I should have shown you the Python application. But for the wanting of time, I will quickly go through that at the end. So I will finish this off first. So this will be a Python application which will do nothing but it takes the Python request, and then if the response is okay. See, response is not computed by the web application, it is provided by the IDP, and this this SAML consumer does nothing but giving you a dummy HTML page, and in that dummy HTML page, if you inspect using any developer tool or the SAML developer tool I am going to discuss, you will be seeing the SAML tokens or the assertions, right? So it's a very dummy basic service. I'll show you that, but quickly we have to talk about the trust because it's a SAML tutorial, not Python. And this audience, like again I mentioned about the entity ID being the one that that actually distinguishes between what is a service provider, right, and what is a IDP, right? So this service provider has an entity ID that is called the audience URL. This is just a dummy URL. It can be anything. Here, in this example, they have given 8080. Let's say that your Python code is running on 7000, then it has to be localhost 7000 / you just give any other string after that. Okay, it can be any string in fact, but it has to be a unique string for the entire thing as such. Now, I think I mentioned about relay state. Okay, relay state is also a very important concept not to be missed. So let's say that which page we have to show when the user has already logged in. It is the page which the user requested for and not the home page always, because we never know that the user has access to something which is defined as the home page. What is the home page defined is actually the list of credit card application page. If the user is just a normal user accountant, he is not supposed to see that, right? So the relay state is whatever page that, let's say if it is an accountant, he is supposed to see the account detail page, right? So this is a summary page. So this relay state you can define as the state which the user has to be sent whenever the login authentication is successful. But in this case, we are not setting any relay state. That's why it is left blank. And again, name ID format, we can specify some name ID format. If I gone through that, I would have shown some other name ID formats. But if you set it to unspecified, then by default Okta will fall back for the application username, which is the next one. And here the application username is nothing but the Okta username. So it will fall back for that. And this username is actually the email ID. So it will fall back to the email ID. Okay, and advanced setting, we are not going to do much on that. Then, like I said, what are we going to check in this? Check that something related to me has shown up, that I am the one who actually signed in. I need to know that first, right? So I will say that you give me the first name and last name as part of the user attributes, and I am omitting the group attributes for now. Okay, and then what you can do is you can preview this SAML assertion. So this metadata that is created, which is needed for concluding the trust process, you can preview. And when you preview it, you will see it like this. In my case, it would be like this. Okay, I will come to this. I will discuss this. But it will be shown like this, or it will be shown like this, right? Yeah, so an assertion. Maybe I got the wrong screenshot, I'm not sure, but yeah, but this is the assertion. So sorry, this is the not the assertion. This is the SAML metadata. Okay, this entity ID. This is actually the response. It's not. I got the wrong URL here. Sorry, because wrong screenshot. But this is what you will see when you go to this page where you do preview, where you click on preview the SAML assertion. You will see this particular page. Okay, we'll come to this. Okay, then you select the first option here, and then you are done. Right now, you have established a trust between the service provider and the identity provider. Right now, again, this is a demo. We'll continuing it by talking something about the request and the response. Right, we have never seen the request and response yet. Right, to even before that, right, I want to show you the service provider. So this is a service provider, and I will be providing you this SAML dummy app. It is in the Udemy course, which was the source for this, and I will be sending you attaching this as zip. Just remind me if I forget. Yeah. So basically, this dummy app just you can run it at port, any port. 8080 is not open for me, so I'm running it on 7000. Okay, and you can verify that this gives you the proper response by having another PowerShell. Again, you have to install Python. Python latest is recommended, right? So here if you see, I'm running this. I mean, I would have already ran this command, curl command with get. If I hit this URL, this 7000 URL, localhost 7000, I get the request. This is all it will return. It doesn't return anything fancy. Okay, but if you inspect this particular network tab, which I will show you, you will see the SAML response, and you can also, when you use the SAML developer tool, you can see the actual response that is verified, or not verified, sorry, that is decoded by the SAML developer tool. Okay, so this is what all the service provider is. Service provider is nothing great, right? Now we will be seeing, going to some ID we will see. Okay, if you don't see ID, then it is not like a coding exercise. So let's see an ID. Let's open Visual Studio. Okay, it's not moving. Okay, so yeah, so you, again the code which I will be sharing will have this request. So this is the request, like I mentioned, right? So you have something like this, right? This is the SSO URL. This is the SSO URL, and you are passing the SAML request to this particular IDP URL. So what is this request? It is an encoded SAML request. So what are you going to encode? You are going to encode a request which is suggested by SAML. So this is what SAML will understand as its own SAML request, but it is not enough that you have this request. The first thing you will do is you will replace all these values, right? We saw the ACS URL, right? Now IDP URL, where do you get it from? Is that you will get the IDP URL from here. So these two URLs are the same URL, but this will be the IDP URL. Okay, and then this is some unique generated key. It can be something SAML 1234, and just put it to a date which is acceptable nearer your date. So I did on 14th or something, so I put 14. So this issuer has an entity ID. This is service provider entity ID, which will be the entity ID I showed you when I created the trust, right? That localhost 7000 / some string, right? It will be that. So what you will see is, you will see this, right? Now what we do here is we are not going to create an application which will encrypt it or do some signing and all that. What we will do is we have also have a handy site. We'll go there, which is called samltool.com validate.php. So maybe I'll put it on this group now only. Yeah, so this particular one, its only job is that you have a request, you can do some operation. You go to online tools, code decode. First you need to do is you need to do a URL encoding. Why? Because you have to send the request to the SAML request parameter, which I showed you in the VB code. So going back to the VB code, here I showed you that this is the URL parameter. So you have to encode it. So you have to do a URL encoding. And in addition to that, the SAML recommendation or not recommendation mandate is that this should be base 64 encoded to begin with, and then you do a URL encoding on top of it. So all this we will do only using this particular thing. So what I'm going to do is I will go to my So we will see how this particular request ended up as this value that you see here, right? So that's what we are going to see. So we copy the entire string, and then you go to deflate base 64 encode. So base 64 encode, you copy paste it, deflate and encode, and we see this is the string, but this again has some encoded characters which you cannot use it in a URL. So you need to do URL encoding. Now how will you do URL encoding? You copy that thing and then you do URL encoding. Now if you see, this exact value is the value that you see in the VB code. That is in this tab. If I copy this, send exact value. Now this is the request which you are interested in, right? Now what happens is, I am going to send this request to the IDP, right? So what you need is, what you need to do before this is, you already logged in, right? How will you know that it is giving you any login page? I told you that the login page is not given by the web application. I have not created any web application, right? I did not get any login page. Now if you copy this, and again, just to make sure that it's not something I made up, right? So like you see, this request is redirecting me to the login page. Now there's one downside when you sign in using GitHub. I would suggest that don't sign in with GitHub. Sign in with a new set of credentials yourself, because GitHub, when I sign in using GitHub, it doesn't send me to the relay state. That is the response I expect from it. That is the Python response. It shows me the home page. Maybe that is an issue with GitHub. But if I execute the request again, then it will show me the correct one. I think that is because GitHub has a way of, it internally has OAuth. Right? For example, as you see, it did not give me the response I want, and the response I want is this. This is the response I want. Right? Because this is the response I showed you here. What does it say? Successfully consumed the SAML assertion. That's all. Now, if you install something called, sorry about my typing. Now if you install a SAML DevTool extension, right? You install this, you will see one this particular thing. This particular tab will be there for you, and if in that tab you can see the request the SAML response, and if you click on the SAML, this particular tab, here you can see the SAML response. Here you can see the SAML response. Okay. Now let's take this response, and again this is the same SAML response. Let's see some of the parts. I mean, I'll wrap it up in some time, but to conclude certain things, I need to make it clear that this response 2 is the value which you mentioned while you set up the trust, and this is the destination you provided, right? And this is, what is this? This is the entity URL which is there in the metadata. You see the metadata. This is the entity URL in the metadata, right? So similar to that, any value that you have configured, that is, you configure the algorithm to be RSA SHA 256, right? And then you configure the digest method to be SHA 256. Only these values that you configured in the metadata can ever be applicable here. And you have two signatures here. You have one signature for the for this part, right, signed info part here, issuer part, this part, and one signature below here. Okay, all these should have the same combination of digest method, signature method. All this should be whatever you have defined before, right? And like we wanted to know how this is what I logged in. So I use something called my email ID, well done Visher, and I got requested for my first name. So I showed you in that initial one, screens, that I asked for a first name which is well done Visher, and I asked for my last name which is well done Visher. So from this I come to know that this is the right one. Okay. So this is the response that you will get. Any doubts so far? I have one last part, if people will allow me. What about it, Sachin? Just want to show how this can be verified in the same tool. Just takes 2 minutes.
Okay. I also ask.
Yeah, it's just a couple of minutes. Now, so this entire SAML response, if in the same tool, validate SAML response. So I'm going to validate this is my response, right? And if you see, these values are what you provided as the entity ID, SP ID, all these are already set for you. And where do you get the X 503? So this one you will get it from the metadata. So it is nothing but this particular value. Okay, so I set it here and I do validate this SAML response.
Oops. You missed one X.
X.
No, the certificate you missed one character.
Is it?
In that 509. You used the first letter.
No.
No, that is correct.
Yeah, sometimes what happens is it expires because I spoke little, right? So that also happens. But the idea is this. Maybe this response payload, I should have taken this particular.
Yeah. You copied in the ID.
Yeah, this thing. I copied. Whether I copied this only? No, I did not copy the XML. I think so. Yeah, it has expired actually. So I will quickly send another, because it has a time before which that's also part of the protocol that it will expire in some time. Okay, so if we do this and we go to SAML and we copy the whole thing, copy, paste it, well done. Okay, it is some issue with the system clock. That mostly happens if you have different timing here. Okay, yeah, but then this is how you will valid. Oh, sorry.
You have to copy it here.
This.
This is the old one. You have to take it from here.
No.
This signature you need to update. Or the same signature?
No, this is this signature, SAML signature.
This signature.
See, sometimes the browser behaves weird, and this you have to put it here. Okay, and this is the X509. Hope I did not miss anything here, right? And sometimes what I have seen is I have to first decrypt it, decode it here. Sometimes that also has happened once. Okay, so this is all you have. I'll come back to this. Okay, I will give you an update on this. But this is, so again the timestamp has expired. I think most likely it is because of the time settings. Because, yeah.
System clock.
Yeah, because again it has got system clock. Usually it will stay for 5 minutes, 10 minutes. So I don't know why it is saying this. But this is how we will verify it. Okay. Any questions?
So maybe after this, you also be having some links like the videos.
Yeah, the links I will be sharing. Yeah. Okay. Anything else? Nothing from the crowd?
So,
Okay. Okay. Thank you so much for attending this.
if you don't have it, body attacks.
Yeah. Mahesh.kr@sacman.com. Yeah.
Thanks, sir.
Okay, Sachin. No problem. Yeah. Bye.
Thank you very much.